Welcome to this AI-generated recap of Shift Left, Secure Your Code and AI from the Start. This session dives deep into how AI is revolutionizing software and application security, empowering us to secure code more effectively and innovate rapidly. Stay tuned for detailed insights and demos from the full session. For years, the number of vulnerabilities in software continues to rise despite advances in detection tools. The root causes are twofold: the overwhelming flood of vulnerability alerts that make it hard to prioritize, and the heavy workload developers face, often leaving little time to properly fix security issues. This persistent challenge slows progress and demands smarter, automated solutions to help teams manage security better. Developers are stretched thin, juggling feature delivery and security fixes. Vulnerability remediation is a costly investment of time and energy, often meaning sacrificing new features or tight deadlines. Until automation fully tackles this, the backlog grows. But with advances like the AI coding copilot, we're seeing a major shift. AI is not only changing how we write code, but also how we secure it, making automation and prioritization possible at a scale we've never seen before. Several demos in the full session illustrate this transformation. AI isn't just reshaping development, it's redefining applications themselves. Large language models, or LLMs, bring unprecedented capabilities, but also new security challenges. As applications become smarter, they also invite more complex attack surfaces. Securing AI-driven software means rethinking our strategies, balancing innovation with rigorous risk management. This session is split into two parts. First, accelerating security remediation with AI, and then exploring securing AI systems themselves as a new frontier. The sheer volume of vulnerability alerts combined with the limited developer time creates a massive barrier to securing applications effectively. To combat this, integration between GitHub and Microsoft Defender for Cloud provides prioritized, risk-focused vulnerability data, factoring in runtime contexts like sensitive data exposure and internet accessibility. Security managers can use this enriched context to launch targeted campaigns that narrow the scope to the most critical vulnerabilities, assigning developers AI-generated fixes directly in their workflow. These fixes are refined through AI-powered checks, ensuring compliance with both security and organizational coding standards, often automatically merging fixes into pull requests. This demo showcases how runtime context, automation, prioritization, and developer productivity come together to drastically reduce risk at scale. For a full walkthrough, check out the connected demo in the complete session. Securing code isn't a one-step process, it's a continuous lifecycle spanning coding to production. This session highlighted a seamless AI-powered workflow integrating GitHub's development stages and Microsoft's deployment processes. AI helps prioritize vulnerabilities based on real-world risk, automates fixes that developers can easily review and approve, and enriches risk assessments with runtime data. This integrated approach transforms security from a reactive chore into a proactive, streamlined operation across the development lifecycle. These capabilities are now in private preview, awaiting developer experience feedback. Sign up to explore it yourself. Modern applications increasingly embed AI components like LLMs, which are inherently probabilistic and non-deterministic. This unpredictability introduces new risks including misinterpretation, hallucination of false content, and security vulnerabilities such as jailbreaks and prompt injections. Unlike traditional architectures where control and data paths are separated, LLMs blend these channels, creating unique challenges that are unfamiliar in classical application security. The solution is clear. Security must be integrated from the very start, shifted left to address both traditional and emerging AI-specific threats within the architecture and development. Jailbreak attacks on LLMs try to override built-in safety prompts, tricking models into ignoring their guardrails. These attacks have evolved dramatically, with methods like skeleton key, crescendo, and context compliance attacker enabling models to produce harmful or restricted outputs despite safeguards. Demonstrations in the full session reveal how persistent and effective such attacks remain, emphasizing the importance of robust, layered defenses in AI security. Prompt injection is another serious threat when AI models process untrusted inputs that are treated as executable commands. Similar to SQL injection attacks in databases, prompt injection manipulates the AI's behavior, potentially leading to harmful or unintended actions. This analogy helps illustrate why sanitizing inputs is critical in AI systems, just as it has been for decades in traditional software security. Examples highlight how subtle prompt injections can hijack AI behavior, like manipulating resume reviews to boost candidate scores, or making malware analysis tools output pirate-themed summaries. In real enterprise scenarios, AI summarizing emails could be tricked into producing emoji-only outputs, revealing how embedded instructions and user inputs undermine system integrity. These practical demonstrations underscore the urgent need for vigilant input validation and prompt injection mitigation in AI-powered applications. Full demos provide further strategies and solutions. A striking real-world attack vector is the cross-prompt injection attack, demonstrated through an enterprise email assistant. By embedding a covert prompt in a seemingly normal email, attackers can trick the assistant, relying on advanced AI models and retrieval-augmented generation into leaking sensitive information, such as full price lists and deepest discounts. This exploit shows just how critical input validation and secure AI workflow design are. The full session includes a detailed demo of this exploit for those wanting a deeper technical understanding. Securing AI-powered applications requires a fundamental shift-left mindset. Viewing risks like jailbreaks and prompt injections as integral parts of development, AI systems' non-deterministic nature means occasional failures are inevitable, which increases security risks if not properly anticipated. Building robust, secure applications means embracing that uncertainty and designing for resilience from the earliest stages. Traditional security controls like access lists are deterministic, but AI systems behave probabilistically, making security mitigation a complex challenge. Think of layered defenses like slices of Swiss cheese, each with holes representing possible vulnerabilities. In AI's case, the size and location of those holes are often unknown, so stacking many layers reduces risk substantially. This layered defense is crucial because attackers try to exploit the holes, and more layers help stop them more effectively. It's a strategic way to manage uncertainty inherent in AI security. Visualizing the development lifecycle helps underscore the value of shifting left finding and fixing risks earlier, ideally at design time where it's cheaper and easier, whether following waterfall or agile methods. Applying early risk mapping, measurement, and mitigation significantly reduces later costs and improves system trustworthiness. Classic security techniques like threat modeling remain relevant, focusing on simple what-if scenarios for each architectural component. We revisit these concepts later with a concrete example involving an email assistant application. Applying the what-if mindset to the email component reveals how untrusted inputs like incoming emails can be manipulated to trick AI models, exploiting well-known vulnerabilities akin to SQL injection. This indirect prompt injection attack exemplifies a devastating security flaw in AI apps if input validation is neglected. Beyond design, detection during build and testing phases is crucial. Tools like Azure AI Foundry's red teaming agent simulate attacks to uncover weaknesses even after coding, though catching them earlier remains preferable for cost and security. Red teaming the email assistant app with Azure AI Foundry reveals the same prompt injection vulnerabilities exposed earlier. Though valuable, identifying these issues post-development is more expensive and reactive compared to design stage prevention. Mitigations become even more critical at deployment, where real-time monitoring and layered defenses help protect live systems. This lifecycle approach, map, measure, mitigate, is key for responsible AI use throughout software development. Built-in mitigations in Azure AI Foundry like prompt shields and content safety filters help detect and block prompt injection attacks before they reach the model. Since these are probabilistic, layering multiple defenses is essential to prevent sophisticated breaches. When combined with runtime monitoring by Microsoft Defender for Cloud and data governance via Microsoft Purview, these tools offer a comprehensive shield, keeping AI applications secure and confidential data protected. For demos of these layers in action, see the full session. Microsoft Purview extends AI app security by enforcing data sensitivity policies with just minimal code changes. This SDK communicates with Purview to block transmission of sensitive data such as GDPR-protected information to AI models, preventing inadvertent leaks. It also supports compliance through detailed auditing and visibility, while being non-intrusive when Purview isn't enabled. Custom policies allow organizations to tailor protections and maintain control. For a hands-on guide, the full session offers demos and resources to explore Purview integration. AI Security Posture Management offers a multi-cloud, end-to-end view of AI workloads through integration with GitHub and Microsoft Defender for Cloud. It inventories AI stacks across platforms like Azure OpenAI, Amazon Bedrock and Google Vertex AI scanning repositories, container images, and infrastructure code for vulnerabilities and misconfigurations. Attack path analysis prioritizes high-risk threats, giving development teams actionable insights to fix issues before deployment and maintain a strong security posture around their AI applications. Revisiting the development lifecycle, the session aligns tools like Defender for Cloud, Purview SDK, AI Foundry's red teaming, and layered mitigations to the phases map, measure, and mitigate. Early in design, threat modeling and education set the foundation. Development integrates continuous risk measurement, while deployment focuses on real-time monitoring and automated defenses. This layered strategy merges decades of software security best practices with AI-specific precautions, enabling teams to shift security left and maintain strong defenses from code creation through runtime. Thanks for joining this deep dive recap of Shift Left, Secure Your Code and AI from the Start. To explore these concepts further, please visit the linked learning resources and try the tools covered. Use the QR code to access hands-on content, including threat modeling exercises and demos, so you can build secure AI-powered applications with confidence. Stay curious and keep securing your code and AI from the very start.